Welcome. We're here to talk about OpenEdge database monitoring. You need more than a VST browser. So in this session, we're going to talk about some of the thinking behind creating an OpenEdge monitoring tool and why you cannot simply point a generic tool to the OpenEdge VSTs with some simple SQL queries. We're going to show you how we've incorporated these techniques into ProTop and how you can take advantage of some of the lessons we've learned along the way and hopefully benefit from that. So for those of you who don't know me, my name is Tom Bascom. I've been a Progress user and a roaming DBA since 1987. Yeah, that was a long time ago. I'm a curmudgeon here at White Star Software, where we provide expert consulting services related to all aspects of Progress and OpenEdge. Switch users are your very active sessions. So you have very, very active sessions. And the reason that this is important is because performance bottlenecks are usually caused by contention for resources. And the biggest users of resources usually follow a Pareto distribution. In other words, a very small number of users are generally responsible for a very large proportion of the activity on the system. So it often pays off to see if you can figure out who the busiest users are and what it is they're doing. So there's a VST called User.io, which is pretty promising. User.io shows you for every user ID who they are and what they're doing in terms of their block access, whether or not they're doing logical reads and writes within the database, as well as the disk access. So are they reading and writing database blocks, BI blocks, AI blocks, that kind of stuff. So if you do a for each user IO by DB access descending, you'll see the users who are most busy. Oh, and your busy users also tend to be, strangely enough, they're the ones who often complain the most and the loudest. Funny thing about that. So user IO, you get output that looks kind of like this. So we're sorted and we clearly see that user number 3119 has 3.3 billion DB accesses. That's a big number, 3.3 billion. I happen to know that in this case, that user is Pro2 replication. So there's a replication process that is basically copying data to a external SQL database. So maybe that's not such a bad number. It depends a lot on how long the database has been up, because one of the things about the activity VSTs is that the data you're looking at is since the database started. So if this database started 3 months ago, or if it's been running for a year, 3 billion might not be such a big number. If it's only been running for a couple of hours, 3 billion is a huge number. Another thing that's missing is that we don't have names for all the users. Blank user IDs are apparently being permitted in this database, so that's not very helpful. It would be nice to know something about who that user is and what type of connection it is. Is it a local self-service connection? Is it a remote connection? What's going on here? You don't really have an indication here or any kind of way to tell whether or not this IO that we're looking at is efficient. There's a lot of it, but we don't know if it's efficient or if it's poorly indexed or what the score is as far as that goes. And we don't know what tables and indexes are involved in this IO. We just see a kind of a big generic number. Oh, they're doing a lot of IO. And of course, we want to know what code there is being run to generate that activity. ProTop removes a bunch of stuff that's basically noise there and then adds in some additional information. So where we see a blank user ID, we've gone out and we've used either the operating system name or the device name or the host that the connection is coming from. So we provide a little bit more information about those unknown, unnamed blank users. We're providing the process ID. So if you need to go out in the operating system and do something like disconnect them, you know who they are. And again, we have the flags that tell us whether it's a shared memory or a remote connection, whether it's a 4GL connection or a SQL connection, whether it's batch, and so on and so forth. And then we're sorted by the block access. So we can see that our busiest user is right at the top here. There's a column for the hit percentage. So this is telling you whether the I/O is efficient or not. Most of these are pretty efficient, but we quickly see that we have one who's doing a lot of OS reads for a relatively small number of accesses. So they're reading in stuff that is not in the buffer cache. This is not terribly efficient. We then have some information about how many record locks are in use by this session. There's a high watermark column. This is 11.7, so it's kind of, well, it's a new feature in the VSTs, and it works kind of strangely. For 4GL users, you get the number of record locks, but you don't get the high watermark. For SQL users, you get the high watermark, but you don't get the number of records that are currently locked. I believe that's fixed in some of the 12-ish OpenEdge 12 releases. Then we have the client statement cache information, where we show the age of the cache as well as the line number and the program name. Now that's useful because if somebody's been sitting or has a query that's been running for a while, you want to know that. You want to know that it's been that the second user here, WMS admin, is doing 500,000 block accesses per second and has been doing that for 2 minutes now. So line 13 of this program is probably something we'd like to take a look at and see if maybe we can't make it more efficient. Or line 3970 of this other program might be a good one to take a look at as well. I mentioned SQL, so sometimes you're suspicious about SQL users, so you can look at them specifically and you can see what SQL statements they've been running. SQL statements tend to be very long, but you can often get enough information from just taking a quick look at the first part of it to have a pretty good idea of what's going on and ask some questions about that of the user, particularly if you're allowing ad hoc queries. And then you want to know frequently about the table and index activity. This also follows a Pareto distribution. Very frequently, only a couple of tables are going to be the most active tables by a long shot. So you'll notice that 2 or 3 or half a dozen tables are extremely busy, and the rest of them all kind of trail off after that. So you want to know what those tables are, whether or not that activity correlates to the busy users, which it frequently does. So it's very easy to infer that the busy lines in the user code are accessing those particular tables. But sometimes it's all spread out all over the place in terms of the users, and it's still useful to know which tables are very active because there may be things you can do about those tables. And we'll perhaps talk about that in just a moment. So the table stat and index stat VSTs look very promising. You can just do a for each table stat no lock and display some information. Same with the index stats. And that looks a little bit like this. So you get the ID, you get how many reads, updates, creates, deletes, whether or not it's been doing an operating system read. Now that's useful because that tells you that it wasn't in the cache. Partition ID, maybe not so useful, at least not unless you're running table partitioning. But again, the VSTs are just giving us raw data. They don't identify for us what the most urgent issue is. The table number is not really all that helpful. It's much more useful to know the table name. There's no way to tell from this really whether or not that information is terribly efficient, nor how the table information relates to the index activity. So here's what ProTop does with that information. So in ProTop, what we've done with the table and index activity is we've added some information. So we tell you what storage area the table has been assigned to, whether or not that table has been assigned to the B1 cache or the B2 cache. We translate the table name and the index name into meaningful metaschema names, and then give you information that we've obtained from DB analysis. So it's really helpful to know whether a table has a long RM chain, for instance, because that impacts the efficiency of adding new records. How many records are in the table? What the percentage fragmentation is, because a highly fragmented record or highly fragmented table with a lot of fragmented records means that you're doing a lot of extra IO operations. Which means that you're much less efficient than you could be. What the scatter factor is, so are things spread out all over the disk, causing the operating system to have to seek back and forth to pull things together. We have this statistic we call churn. Churn is the number of times that you could have read the whole table during the sample period. So if you have a very small table, like this one here with 38 records in it, and you read it a lot, you're turning that over and over and over. And that means that you're wasting a lot of CPU cycles, and you're probably driving a lot of CPU contention and resource contention. And this may be the source of a lot of bottlenecks. So that's a number that you want to pay attention to. On the index side of things, we know how many blocks are in the index, what the utilization of that index is. So is this an opportunity to run an IDX compact to make things more efficient? How many index levels, what the index root block is. If that shows up on your resources that you're having to wait for, remember back on the transaction screen, there was a wait reason. If that index root block is popping up a lot, that means that you've got a lot of contention for that. And whether or not the index is a primary index or a unique index or a word index or what it is. Typically, you're going to see kind of a correspondence between the tables that are active. So here we see SCRM valid queue is the most active table, and the index for that is going to be, there's usually only one index most of the time, not always, but it usually has very similar number of read operations, so that in that sense, they're balanced. But you might see cases where you're doing a great deal more reads on the index, or multiple indexes are doing a lot of reads in an unbalanced way. So that's usually because the where clause is inefficient, and there's an opportunity for you to improve the where clause by looking at the code and figuring out what's going on at that level. So when I'm talking about churn, for instance, we had a recent issue with a customer where they had a very, very large churn that was accounting for about just the access to that one table, one very small table, similar to this, was about 40% of the CPU time on the system. It was holding back their capability to scale. They wanted to basically double their business, and that would put them pretty much at the limit of, well, put them over the limit of what that server could do. So we were looking at that situation. We discovered that because they were churning so hard on that table, and the table was essentially a read-only table, by turning it into a temp table and making it a global, yeah, okay. Pretend you don't hear this if you're, a coding purist, but by turning that table into a global shared temp table, we eliminated 40% of the CPU utilization on the server without having to change the application code, which would have required thousands of changes spread across the entire application. So we're able to very quickly, within a couple of hours of effort, relieve that performance penalty, and then in theory anyway, the coders can make the longer term changes that are needed there, but it might be a while before that actually happens.